Our next topic from the chapter measurement and experiment is the systems of unit. Earlier we have learned about the fundamental or the basic units as well as the derived units, right? So now we will go for the systems of unit. In mechanics we are having three fundamental units. These are the length, mass and time, right? So for the units of these three basic quantities, we are having three systems that we used earlier. First is Cgs, or also you can say French system, right? Where C stands for centimeter, that is the unit of length in Cgs, right? G stands for gram, and gram is what? It is the unit of mass. And S stands for seconds, and this is what? It is a unit of time. This is a Cgs system. Another system we are having FPS, and this is also called the Prefix system, right? Where F stands for foot, P stands for the pound, and S stands for the second, where this foot is the unit of length, pound is the unit of mass, and second is the unit of time. This is our FPS system. And last one is your MKS. MKS system, or you can say it metric system. In metric system, M stands for meter. Meter is the unit of length, right? K stands for kilogram, and kilogram is what? It is the unit of mass. And last, S is for second, and this is unit of time. So we are having three systems: Cgs, FPS and MKS, and with their names also you can get their full forms. So all the above mentioned systems are no longer in use because they were used in historical importance, but now we use the SI systems of unit, right? And SI systems are what? These are the modified or the enlarged version of MKS, right? Nowadays what we are following, the SI system. In SI system, what is the unit of length? Meter. If I am saying the SI unit of mass, that is kilogram. If the SI unit of time, if I am asking, that will be the second, right? But in MKS system, only three quantities were included. Now I am saying this MKS was enlarged and modified, right, to get SI system. In enlargement or modified system, what we have done, we used another fundamental units over there in the MKS system that I will explain you now. So in SI system, what is that? The standard international, right? In that it was recommended that the addition to the units of length, mass and time, other units like temperature, right? Then we are having luminous intensity. Then I am having current, and the unit of amount of substance was also taken as the fundamental unit, and 2 units, that is the unit of angle and solid angle. The unit of angle and solid angle, they were taken as the complementary fundamental unit. I am making the table over here. So what the quantities I am having in SI system? Quantities will be length, mass, time, temperature, luminous intensity, and amount of substance. And current. These are the fundamental quantities I am using, and the unit of length is what? If I am saying unit of length is what? Meter, right? And what is the symbol? Symbol is meter, right? The unit of mass is kilogram, and the symbol is kg. The unit of time, second, and it is denoted by S. Unit of temperature, SI unit of temperature is what? Kelvin, denoted by K. Luminous intensity, the unit is what? Candela, and it is denoted by Ct. Next, the amount of substance is what? Mole, right? And denoted by mol. And the last, current. The unit of current is what? Ampere. And the symbol, the electric symbol is what? A, right? Now I said 2 units, that is angle and the solid angle. They were used as the complementary fundamental unit. So what was that? Angle is what? Radian, and it is denoted by RD. And last, solid angle, and it is steradian, and symbol is. So these are the fundamental quantities that were included in the SI system, where these two are the complementary fundamental units. So if it is being asked what are the fundamental quantities in SI system, so all these will be the fundamental quantity and these one will be the complementary fundamental quantities. So SI system is what? It is the standard international system, and that is the enlarged or the modified version of MKS system. Next is the use of prefix with a. Whenever we are doing the measurement, we need to measure the smaller quantity as well as the larger quantities, right? So according to that, we need to use the prefixes with the unit, just like gigahertz, kilometer, right? So for that we need the units prefixes for the bigger measurement. I have written over here all the prefixes. Now I will explain you the meaning of that. These are for the bigger measurement, right? So deca, the symbol is what? It is Ga, and the meaning is 10's power 1. Hecto, the symbol is H, and the meaning is 10's power 2. Kilo, symbol is K, right? And it's 10's power 3. Just like if I am putting kilo in front of meter, so it will become kilometer, and it will become 10's power 3 meter, right? Mega, the symbol is M, and its meaning is 10's power 6. Next is giga, the capital G, the meaning is 10's power 9. Next comes the tera. Tera is circuit the symbol is T, and the value is 10's power 12. Next comes peta. Its symbol is P, and the value is 10's power 15. Hexa, its symbol is E, and the value is 10's power 18. Zeta, the symbol is Z, and the value is 10's power 21. Last one, iota. Its symbol is Y, and its value is 10's power 24. For example, if the frequency is given 22.5 gigahertz, right? Over here, hertz is what? It is the SI unit of frequency, but some prefix is there, and prefix is what? Giga, right? That means, what is the meaning of giga over here? 2.5 into giga is what? From here I can check, it is 10 power 9. So I can write 2.5 into 10 power 9 hertz, right? This giga, I have converted, gigahertz has been converted into the hertz, right? For example, another example, if I say the picofarad, 5 picofarad, right? It means what?
Start.
So pico over here, it is the prefix for the smaller measurement that I am going to explain you next, and how to convert it into the farad, right? Next. So here are the prefixes for the smaller measurement. So first is deci. Deci, the symbol is small d, and its meaning is what? 10 power minus 1, right? That means if I am writing, for example, decimeter. So how much meter? 1 decimeter is equal to 10 power minus 1 meter. Centi, the symbol is C, and the value is 10 power minus 2, right? Next is milli, small m, the symbol, and the value is 10 power minus 3. Next comes micro. Micro, the symbol is this micro, and the value is 10 power minus 6. Nano, symbol is N, and the value is 10 power minus 9. Pico, its symbol is either P you can use, or either 2 micron you can use, and the value is 10 power minus 12. Why 2 micro? See, 1 micro is 10 power minus 6, right? Micro into micro, so it will become 10 power minus 12. Next is femto. Femto, the symbol is F, and the value is 10 power minus 15. Atto, its symbol is A, and its value or its meaning is 10 power minus 18. Next is Zapto. It is smaller z, and the value is how much? 10 power minus 21. Last one is Yoto. Its symbol is small y, and the value is 10 power minus 24, right? So these are all the prefixes for the smaller measurement. For example, I can take the example if I am having, just I said 5 picofarad, right? So 5 pico. Pico means to say over here, we can conclude pico means to 10 power minus 12. So what I can write? 5 into 10 power minus 12 farad, right? So this will become the unit. Similarly, if I am saying 5 mega ohm, this is what? The smaller or the bigger? It one is bigger, right? From the bigger, mega means to say 6. So 5 into 10 power 6 ohm. So just by using the prefixes for the smaller measurement as well as the larger measurement, we can get the values in a proper manner, right? Just for you need to learn the values, like centi means to say what, micro means to say what, giga means to say what. So accordingly you can convert into the smaller or the relative units. Next we will learn about the unit of length. So next is unit of length. SI unit of length is what? SI unit of length is, a lot of times I have told you, it is meter, and the symbol is m. Now that is the SI unit, but as I said, in the measurement we need to measure the smaller quantities as well as the larger quantities. For example, if I am drawing a line over here, now I will measure the size of this line in kilometer or meter or in centimeter. As it is a smaller one, so I can conclude in the centimeter. But if I want to calculate the distance between two cities, so will you calculate in centimeter? No. What you will use in that case? Kilometer. right? So depending upon the situation, you need to choose the unit of the length, right? So over here I'm going to tell you about the subunits as well as the multiple units of length. Whenever I'm saying the subunits of length, right? Subunits of length means to say for the measurement of the small length. Subunits are being used for the measurement of the small length, right? Because meter, in that case, it will become the bigger unit. So most commonly subunits are centimeter, millimeter, micron, and last nanometer. So these are the subunit. Now what are the relations of these units with the meter? 1 centimeter is equal to how much? It's 1 upon 100 meter, or either I can write 10 power minus 2 meter, right? Next, millimeter. 1 millimeter is equal to what? It is 1 upon 1000 meter, or I can say 10 power minus 3 meter, right? Next is 1 micrometer. 1 micrometer is what? 1 upon or you can say 10 power minus 6 meter, right? Similarly, if I am saying nanometer, nanometer means to say it is 10 power minus 9 meter, right? So you can convert the smaller unit into the SI unit accordingly, right? So these are the subunits of the length, or the, you can say, or the units for the measurement of the smaller length, right? Next is the multiple units of the meter. Multiple means to say for the measurement of the larger units. Next is the multiple units of the meter. Multiple means to say for the measurement of the larger units. As I said, multiple of unit is what? It is the measurement for the larger length, and because in that case meter is too small to calculate a unit. For example, if I want to calculate the distance in between two heavenly bodies, right, or distance in between the star and the earth, right, or either in between two cities, so can I use the unit of meter in that case? No, I need to have the multiple units of the meter, right? So multiple units of the meter, the most commonly used multiple unit of meter is kilometer. And kilometer is what? 10 power 3 meter, right? So further we are having some non-metric units of length. Now non-metric units of length, these are the bigger units, very bigger from the kilometer also, right? So you can say for the measurement of the distance between two heavenly bodies, in that case kilometer will be too small. If I am saying the distance between the earth and the Jupiter, so will you calculate the distance in kilometer? No. For that you need, for that purpose you need to have more larger unit. In that case we are commonly using astronomical unit. Second, I am having light year. Third is Parsec, right? So these are the very bigger units for the unit of length. So first is what? As I said, astronomical unit. Astronomical unit is what? It is equal to the mean distance between earth and sun. What I am saying, it is the mean distance between earth and sun, right? And what its value? It is denoted by AU, and 1 AU is equal to 1.496 into 10 power 11 meter. This is our astronomical unit, right? Second is light year. Now, light year is what? A light year is the distance traveled by light in vacuum in 1 year. What I am saying, distance traveled by light in vacuum in 1 year. Right? I am saying distance travel. Okay. What is the distance? Distance is what? Speed into time. Right? Now, what is the speed of light? It is 3 into 10 power 8 meter per second. Right? Into time. Time is how much? I said 1 year. 1 year means to say 365 days. So, what is the SI unit of time? It is second. That means 365 you need to convert it into second. So, whenever you are converting it into the second, the answer will become 9.46 10 power 15 meter. So, 1 light year is equal to 9.46 into 10 power meter. So, the distance of stars from the earth is generally expressed in light year. So, what I have calculated, light year, 1 light year is equal to how much? 9.46 into 10 power 15 meter. Now, if I want to convert into the kilometer, it will become 9.46 into 10 power 12 kilometer. Further, units are 1 light minute, right? What will be the difference? It was year. So, time was taken in year. Year was converted into the second. But now, if I am taking the minute, the time minute will be taken and then minute will be converted into the second. So, it will become 10 power 3 into 10 power 8 into 1 minute is equal to how much second? 60. So, it will become 1.8 into 10 power 10 meter. Another unit is 1 light second. So, 3 into 10 power 8 into 1. So, it will become 3 into 10 power 8 meter. So, these are the light year or the another unit. Next is parsec. What is parsec? It is the distance from where the semi-major axis of orbit, what I am saying is the distance from where the semi-major axis of orbit of Earth, that is 1 AU, subtends an angle of 1 second, right? This is called your parsec. And what is the relation between parsec and light year? So 1 parsec is equal to 3.08 into 10 power 16 meter. Another, you can say 3.26 light year, right? These are the larger unit for the measurement of this length. Now, if I am saying for the smaller unit, if I am saying the smaller unit, these are the larger ones, just to calculate the distance in between two heavenly bodies or the stars or the sun and earth and all. Now, if I said that you need to calculate the size of the nucleus, then can you use kilometer, meter and all? So for that you need the further smaller units. So smaller units means to say to express the wavelength of light, size and separation between two molecules, because these are very small. In that case, you need the smaller unit, right? Just like the radius of orbit of electron, and these units are smaller units. First I am writing, this is Armstrong and it is denoted by A0, and this is equal to 10 power minus 10 meter. Next I am having the smaller unit, that is Fermi, and Fermi is what? It is 10 power minus 15 part of a meter, right? So I can write 1 Fermi is equal to 10 power minus 15 meter. So these are these commonly used smaller and bigger units of length are summarized like that. So I will give you the table for that, how what is the relation in between smaller and bigger unit. So this is all about the units of length, right? The smaller units, the bigger units, for the length of this one, the spaces bodies, right, for the molecules. So you need to convert smaller into bigger or bigger into smaller, right? So this is all about the unit of length.